Okay, so today we're going to solve equations that contain fractions. If you take a look at this whole page, all fractions in those equations. But that's okay. We can still solve for the value of x in each of these. And the first type we're going to solve is called the cross-multiplying type. Cross-multiplying is a process you use to solve for the missing piece in a proportion. Remember, a proportion is just two fractions set equal to each other, like this. And if one of those four pieces is missing, you can cross-multiply to solve for it. Well, if you take a look at exercise 1A, on the left side we have ourselves a fraction. I mean, the top of it, the numerator is kind of a mess, but it is a numerator over a denominator, so it is a fraction. And on the right side of the equation we have a 9, but we know that we can put 9 over 1, and it's equivalent to 9. Now we have a fraction set equal to a fraction. So this is actually a proportion. We can cross-multiply to solve it. We go diagonally this way. 1 times 6 parenthesis x plus 2 just gives us 6 parenthesis x plus 2. Multiplying by 1 doesn't change anything. The equals goes in the middle. And now we're going to multiply this way. 4 times 9 gives you 36. Look, our fractions are gone. And we know how to solve this. To get rid of the parentheses, we distribute. 6 times x gives me 6x. 6 times 2 gives me 12 equals 36. To get that x by itself, I'm going to subtract 12 from both sides. And with 6x equals 36 minus 12 is 24. Dividing by 6 on both sides, I end up with x equals 4. 24 divided by 6 is 4. Now, as we talked about previously in set notation, here's what that would look like. X such that x is equal to 4. In letter B, same situation. We have a fraction on the left side. This time the top and the bottom is an expression, but it's still a fraction. And on the right side we have a 2, which we can put over 1 to turn into a fraction. We now have a proportion. We can cross-multiply to solve this. Now, when I do 1 times 3x plus 5, technically I could write it this way. 1 times 3x plus 5. The equals goes in the middle. And then when I do 2 times 2x minus 1, it's going to look like this. Now, typically when you multiply 1 times 3x plus 5, you would just write 3x plus 5 because distributing a 1 through the parentheses doesn't change anything. The reason I wrote it this way for you today is because I just want you to see the difference between when you're multiplying by 1 and when you're multiplying by a number greater than 1, like 2. It really does have to get distributed through the parentheses. On this side, we're left with 3x plus 5. On this side, you're going to get 2 times 2x, which is 4x, and 2 times negative 1, which is negative 2. This one's a little different than letter A because now we have a variable on both sides. We have to get the variable to one side, so I'm going to subtract 3x from both sides. I certainly could have subtracted 4x from both sides as well, but I like to keep my x variable positive. These cancel. I'm left with 5 is equal to 1x minus 2. 1x comes from taking 4x and subtracting 3x from it. Adding 2 to both sides, you see that x is equal to 7. On this next one, you have a fraction on the left side and this expression on the right side. Well, still, even though that's an expression, you can put the whole thing over 1. Make it look like a fraction, and now we can cross-multiply to solve it. 2x times 1 gives me 2x. The equals goes in the middle. And then we're going to do 3 times 14 minus 4x. When we distribute to get rid of the parentheses, 3 times 14 is 42. 3 times negative 4x is negative 12x. Again, we have the variable on both sides. Your goal is to get the variable on one side and a number on the other side. Well, since we already have the number on the right side, I'm going to get rid of the 12x. Add 12x to both sides. 2x plus 12x gives me 14x. These cancel. I'm left with 14x equals 42. Dividing both sides by 14, 42 divided by 14 is 3. X is equal to 3. Now when we take a look at these next examples, you're going to see a little difference here. Let's say that the x over 5 and the plus sign were not there, that this piece here were gone. If you covered that up with your finger, you would just see that it was x over 2 equals 14. You could put the 14 over 1 and cross multiply to solve it. You actually cannot cross multiply to solve this one yet, because it's not a fraction set equal to a fraction, it's a sum of two fractions set equal to a fraction. So in order to cross multiply, we have to first find the sum of x over 5 and x over 2. Now back in Ms. Dromgold's class, when you learned how to add fractions, you learned that you need a common denominator. Our denominators are 5 and 2. So I'm going to use 10 as my common denominator, because 5 is a factor of 10 and 2 is a factor of 10. Well, if we change the denominator to 10, the numerator has to change as well for the fraction to remain equivalent. Well, 5 times 2 gave me 10, so I just need to multiply the numerator by 2 as well, giving me 2x. And 2 times 5 gives me 10, so I just have to multiply the numerator by 5 as well, and it gives me 5x. And now I can add these fractions together. 2x over 10 plus 5x over 10 gives me 7x's over 10. I can set that equal to 14 over 1. And now that we've added those fractions, we have a fraction set equal to a fraction. We can cross multiply to solve it. 7x times 1 gives me 7x. The equals goes in the middle. And 10 times 14 gives me 140. I end up with 7x equals 140. To finish getting x by itself, I divide both sides by 7, and 140 divided by 7 is 20. You get x equals 20. In set notation, again, x such that x equals 20. You will never get points off if you don't write your answer in set notation. I just want you to be familiar with it in case on a multiple choice question the state decides to write their answers in set notation. Or in case the directions ever simply say write your answer in set notation. It could happen. On this next one again, we've got to actually add these fractions together before we can cross multiply. Hold on one second, I got to let Murphy in. Alright, so again, this next one we have to add these fractions first. Our denominators are 2 and 6. I'm going to use 6 as my common denominator, because 2 goes into 6 and so does 6. 2 goes into 6 3 times. Multiplying the numerator by 3, I get 3x here. We didn't change the denominator here, so the numerator doesn't change either. 3x over 6 plus 1x over 6 gives me 4x over 6. I can put the 2 over 1. I now have a fraction set equal to a fraction, so I can cross multiply. 4x times 1 is 4x. The equals goes in the middle. 6 times 2 is 12. Dividing both sides by 4. 12 divided by 4, you see x equals 3. Now this next one, again, it looks like you can use 6 as your common denominator, because 3 goes into 6, and obviously so does 6. 3 goes into 6 2 times. Multiplying the numerator by 2, 2 times 2x gives me 4x. 2x over 3 is equivalent to 4x over 6. This one doesn't change. 4x over 6 plus 1x over 6 is 5x over 6. I can put the 5 over 1, and now I can cross multiply. Oh, I wish I could videotape my dog right now. For some reason, he doesn't realize that that tail is attached. Cross multiplying 5x times 1 gives us 5x. The equals goes in the middle. 6 times 5 gives you 30. Dividing both sides by 5, you see that x is equal to 6 because 30 divided by 5 is 6. So that's when you have a sum set equal to a number. Before you can cross multiply, you have to add the fractions together. It could also happen with a difference. You would have to subtract the fractions, but you'd use the same process. Excuse me. You might be wondering why I rewrote the same 3 equations again. I did that because I'm going to teach you a second method where when you have a sum or a difference set equal to a number. And this is what the math teachers at Odyssey call the I hate fractions method. If you like this method better than the common denominator method, then go ahead and use it. Doesn't matter to me which one you use as long as you know what you're doing and you get the right answer. Here's how you use the I hate fractions method. You basically take a look at the two denominators you want to get rid of. In this first one, we want to get rid of a 5 and a 2. So what you do is you take the denominators you're trying to get rid of and you multiply each term in the equation by that 5 and that 2. Even this guy out here. You got to do every single term in the equation because otherwise you won't keep the equation balanced or equivalent to the original equation. Now look what happens when we do that. In this first term, we have a 5 in the top and a 5 in the bottom. Guess what? Those cancel out. You're left with just 2 times x, which is 2x. In this second term, this 2 in the bottom cancels with this 2 in the top. You're left with 5 times x, or just plus 5x. On this side, you have nothing to cancel with in the bottom because this 14 is just over 1. So you just multiply 14 times 5 times 2. Well, 5 times 2 is 10. 10 times 14 is 140. See? You hated fractions, so you got rid of them. Now we can combine like terms. We end up with 7x equals 140 because 2x plus 5x is 7x. Dividing by 7 on both sides, 140 divided by 7 is 20. And 20 is the same thing we got up here. We got x equals 20. Just used a different method of solving. In this next one, the fractions we want to get rid of, or excuse me, the denominators we want to get rid of are 2 and 6. So I'm going to multiply this term by 2 and by 6. This term by 2 and by 6. And even this term over here by 2 and by 6. Now this 2 in the bottom cancels with this 2 in the top. I'm left with 6 times x, which is just 6x. This 6 in the bottom cancels with this 6 in the top. I'm left with 2 times x, or just 2x. And on this side I have 2 times 2, which is 4, times 6, which is 24. Combining like terms, 6x plus 2x is 8x. I end up with 8x equals 24. Dividing both sides by 8, you get x equals 3. On this last one, I apologize there's not a lot of room, but the denominators we want to get rid of are 3 and 6. So I'm going to multiply this term by 3 and by 6. I'm going to multiply this middle term by 3 and by 6. And even the 5 gets multiplied by 3 and by 6. 3 in the bottom cancels with the 3 in the top. I'm left with 6 times 2x, which is 12x. 6 in the bottom cancels with the 6 in the top. I'm left with 3 times x, which is just 3x. 5 times 3 is 15. 15 times 6 is 90. I'm left with 12x plus 3x equals 90. Combining my like terms, 12x plus 3x is 15x. I get 15x equals 90. Dividing both sides by 15, I get x equals 6. 90 divided by 15 is 6. Same thing we got up top, we just used the I hate fractions method instead of the common denominator method. So when you come into class next time, be ready to work with these equations involving fractions and have your notes ready to show me, and have a wonderful night. Okay, so today we're going to talk about a concept called literal equations. We've been solving equations so far in Unit 2 where there's a number as an answer. Or maybe there's no answer, or maybe there's an infinite number of numbers that are solutions. With literal equations, hold on one second. With literal equations, there's actually no number as your solution. You end up with an expression that's the solution to the equation. So here in exercise 1, we're going to solve each of these equations for the value of x, which, as you know, means get x by itself. So first we'll solve one that is not a literal equation, but an equation where there will be one number as your answer. 5x plus 3 equals 33. You can see there's only one variable in there to solve for. It's x. And it's pretty simple to solve for it. To get x by itself, we would subtract 3 from both sides. That gives you 5x equals 33 minus 3 is 30. To finish, divide both sides by 5. And you see that the value of x that makes the equation true is 6. This next example is what we call a literal equation. Instead of 5x plus 3 equals 33, we have ax plus b equals c. It still has an x in there that we can solve for, but we certainly won't be able to come up with an answer like x equals 6 because we don't know what a, b, and c are. But we are going to use the exact same method to get x by itself. Over here, we had plus 3, so we subtracted 3 from both sides. Over here, we have plus b, so we're going to subtract b from both sides. The b's cancel. You're left with a times x is equal to, well, we can't come up with one value for c minus b like we did over here. 33 minus 3 was 30. All we can do is write the expression c minus b. Now, over here, we had 5x equals 30, so we divided both sides by 5 to get our answer. We're going to do the same thing here. We have x times a. We're going to divide both sides by a to get our answer. You're left with x equals c minus b over a. And that's your answer. Notice the answer is not a number. The answer is actually an expression. All right, let's take a look at a couple more examples. You'll see the two examples in exercise 2 look pretty much the same in terms of format, but this one will come up with a numerical answer. This one is a literal equation. Remember, a literal equation is an equation where there's more than one variable, and you're just asked to solve for one of those variables. So let's solve the numerical equation first, because that we're good at. We have to get this fraction that contains the x by itself, so to do that we're going to add 7 to both sides. So we end up with x plus 5 over 2 is equal to 3 plus 7 is 10. Now putting the 10 over a 1, we can cross multiply to solve this proportion. 1 times x plus 5 is x plus 5. The equals goes in the middle, and 2 times 10 is 20. Subtracting 5 from both sides, we end up with an x value of 20 minus 5, or 15. On this side, we're going to use the exact same steps, but again, we're going to end up with an expression as our answer instead of a number like 15. Going to get this fraction by itself by adding c to both sides. We end up with x plus a over b is equal to, again, when we do, oh, look, I made a mistake. Let me back up. That should have said plus c. to both sides. We end up on this side with not a number, but with an expression d plus c, which I can still put over 1 and cross multiply to solve. 1 times x plus a is x plus a. The equals goes in the middle. And b times d plus c will look like this. b times d plus c. So we almost have the x by itself here, just like we almost had x by itself here. To get x finally by itself, we subtracted 5 from both sides. So to get x finally by itself over here, we're going to subtract a from both sides. You end up with an x equal to a b times a d plus c minus an a. There's your expression. It's also your solution to this literal equation. All right, number 3 is a multiple choice question. And I put this on here purposely because I like for kids to think about multiple choice questions when they see them on the Regents exam as non-multiple choice questions. I want you to pretend that these answers aren't here, because if you look at the answers first, a lot of times these answers are written very systematically. The person that wrote this problem knows the common mistakes you're going to make. So sometimes looking at the answers first is not a good idea because some of those distractor answers lead you in the wrong direction. So let's just pretend those aren't there. And we'll rewrite this equation over here. And we're being asked to solve for x in terms of h and k. We've heard that before. We've talked about how find the area of the circle in terms of pi means that you're going to have the pi symbol in your answer. Well, solving for x in terms of h and k means that your expression, that is the solution to this literal equation, is going to have an h and a k in it. So here's the variable we're trying to get by itself. Keep in mind also that you could be asked to solve for k in terms of h and x. You just got to read the directions. Hold on, I got to let the dog out. Okay, Murphy was under my bed, eating the lining from the box spring. I just went to take him outside. He's not going outside, so I closed my door. He'll probably start barking. We'll just have to ignore him. All right, so the first thing to get x by itself here is let's get rid of this plus k by doing minus k to both sides. We're just going to take step by step and try and get that x all by itself. On this side, we end up with 2 times x minus h equals 8 minus k. Well, the next thing we need to do is try and get at least this parentheses containing the x by itself. And it's multiplied by 2. So the opposite of multiplying by 2 is dividing by 2. You end up with just, since these 2's cancel, x minus h equals 8 minus k over 2. So we're almost there. X is almost by itself. It still has a minus h stuck to it, so we're going to add h to both sides. These h's cancel. You're left with x equals, you've got 8 minus k over 2 plus h. Now, if you take a look at our answer choices, I don't see this up there as an answer, which means that the person that wrote this problem must have simplified our solution a little bit further. So let's see what we can do to simplify this a little bit further, and hopefully our simplified version of the answer will show up as an answer choice. Remember, dividing 8 minus k by 2, that's the same as doing this. 8 divided by 2 minus k divided by 2 plus h. Well, 8 divided by 2 is 4. So do we have an expression up there that says 4 minus k divided by 2 plus h? We do, right here. It's written in a little bit of the different order, but the 4 is still positive, the h is positive, and the k over 2 is negative. And the commutative property for addition allows us to switch the order, so that is equivalent to the answer that we got. Now we're going to look at a couple examples where we have to get the variable to one side. Again, we'd like to solve this equation for x. And let's start with the situation where we know the values of a, b, c, and d. Okay, here you've got an 8x on the left side, a 5x on the right side. So I'm going to get the variable to one side by subtracting 5x from both sides. 8x minus 5x is 3x, plus 1 equals the 5x minus 5x cancel. You're left with 22 over here. To continue getting x by itself, we subtract 1 from both sides. You get 3x equals 21. Finally, dividing both sides by 3 gives you a solution of x equals 7. Now we're going to solve the exact same equation, but we're replacing the 8 with an a, the 1 with a b, the 5 with a c, and the 22 with a d. But we're going to solve it the exact same way. We'll start by subtracting ax to both sides, like we did in the first equation. So you're left with b is equal to cx plus d minus ax. Well, now we've got 3 terms on this side. Only 2 of them have an x in it. And that's okay, but let's get rid of any terms on this side that don't have an x in it, like the plus d. To get rid of plus d, we're going to subtract d from both sides. So we get b minus d equals cx minus ax. I've seen that they like to put this type of literal equation on the Regents exam a lot because it practices a skill that we haven't even gotten to yet called factoring. So this is really cool that we're going to talk about it now because it'll give you a little heads up as to what you're going to be doing a lot of later in the year. When you're solving a literal equation, if you get down to having the x on one side only, but instead of it being in one term like it was here, it ends up in 2 terms like it is here, think about how you're going to get the x by itself. You can't divide this piece by c and this piece by a. Can't do that. We have to somehow figure out how to isolate the x. Well, we've done a lot of distributing. To isolate this x, we're going to do a process called undistributing. You'll notice that there is an x in both of these terms. So what if we were to pull that x out of both of those terms and undistribute? What expression would have had to be in here if when we distributed the x, we ended up with cx minus ax? Well, it would have to be c minus a. Let's just check and make sure this is right. Is x times c equal to cx? Yeah, it is. Is x times negative a equal to negative ax? Yes, it is. And by undistributing, which another word for that is factoring, what we've done is we've isolated this x all by itself here. It's multiplied by c minus a, but we know how to unmultiply by c minus a. We divide both sides by c minus a. These cancel. You're left with x is equal to b minus d over c minus a. Let's see if we can do another one where this is the case, where we have to do some undistributing to get the x by itself. We're going to solve for x in terms of a, k, and h. Let's come down here and rewrite this. Ax minus k equals 3 times the sum of x and h. Well, we've already learned that we distribute to get rid of parentheses, so even in a literal equation, we could do that. we end up with ax minus k equals 3 times x is 3x, 3 times h is 3h. Well, we got variables on both sides. Let's get the variable on one side. I'm going to do minus 3x here and minus 3x over here. So now I have ax minus 3x. Oops. I have a minus k over here equals just 3h over here. You can tell already that you're probably going to have to do the undistributing because you see an x in both terms, but before you do that, you have to make sure those are the only terms on this side. So let's get rid of the minus k by adding k to both sides. So now we have ax minus 3x equals 3h plus k. So now again, we're stuck in the same situations. Not a big deal, but instead of having the x in one term, we have the x in two terms. So the only way you can isolate that x is to factor it out or undistribute. Let's pull the x outside the parentheses and think about what would be left in the parentheses. Well, if when we distributed the x, we got ax minus 3x, that must mean there was an a minus 3 in here. Sure enough, x times a gives you ax. X times negative 3 gives you negative 3x. We just undistributed to get that x by itself. Now that x is multiplied by the quantity a minus 3, we just have to unmultiply by a minus 3 or divide by a minus 3. You're left with x is equal to 3h plus k over a minus 3. Look at your answer choices. It looks like it's choice A. So hopefully you guys got all these notes down. I've modeled for you how I want you to take notes. This is what I need you to do. Probably took us about 12 to 15 minutes. I'm not really sure. But we're done, and now we're going to practice this skill. Okay, so I'm going to go over the Unit 1 test with you guys. If you got all the multiple choice correct, some of you did, feel free to just fast forward. Just make sure you understand the ones on the test that you did get incorrect. We'll start with number 1. Number 1 was a little tricky because of these words less than. It says 2 less than 18 times a number. When you see those words less than, you got to think about the order in which you need to write the numbers you're subtracting. 18 times a number, not knowing what the number is, we'll use x to represent it. That would look like this, 18x. If I want to take 2 less than that, that means I have to subtract 2 from it. But if you look at this answer choice, this is what most kids choose who get this problem incorrect. 2 minus 18x. Choice B is not correct because it represents 18 times a number less than 2. The correct answer choice here was choice C, 18x minus 2. In number 2, it says evaluate the algebraic expression when x is 5 and y is 3. Again, forget about those multiple choice answers that are there, and let's just pretend they're not there and try and do this work. I'm going to replace x with 5. I'm going to replace y with 3, and then I'm going to square it. Parentheses first, 5 plus 3 is 8. I end up with 6 times 8 squared. Those of you that did 6 times 8 and got 48 and then squared that, you ended up with choice B, 2,304. Doesn't surprise me it's an answer choice because typically the answer choices in a multiple choice problem are ones that represent common mistakes students make. But if you think of PEMDAS, E stands for exponents. You have to do exponents before you multiply. 8 squared means 8 times 8. 8 times 8 is 64. you end up with 6 times 64, which is 384. In number 3, you're asked to multiply these two binomials. When you multiply two binomials, you have to double distribute. So we start by doing 3x times 2x, which is 6x squared. Then 3x times 6, which is 18x. Now I take this second term in the first parentheses and distribute it through the second set of parentheses. Negative 2 times 2x is negative 4x. And negative 2 times 6 is negative 12. Combining my two middle terms, 18x minus 4x is 14x. I end up with 6x squared plus 14x minus 12. The answer was choice C. A lot of people just did 3x times 2x, which is 6x squared, and did negative 2 times 6, which is negative 12. A lot of kids did 3x times 2x, which is 6x squared, and then did 6 minus 2, which is 4, and got choice C. So be careful when you're multiplying binomials, you have to double distribute. In number 4, a rectangular garden has a length of 5a plus 17. I always say, draw yourself a picture so you can kind of visualize what's being told to you. It has a width of 4a, and we want an expression to represent the area. Area is length times width, or because of the commutative property, you could say it's width times length. You should have multiplied 4a times 5a plus 17. That doesn't appear as an answer, so they must have written the answer in simplest form. Distributing 4a times 5a is 20a squared. 4a times 17 is 68a. The answer is choice C. Okay, number 5 is one like we saw back in the beginning of Unit 1 when we were evaluating expressions. This time we're going to find the value of a minus b when x is negative 2. Again, ignore the answer choices. Let's figure it out by hand first. Let's first find a. A is the expression 2x squared minus 5. I'm going to replace the x with negative 2, giving me 2 times negative 2 squared minus 5. Have to be careful here because many of you will do 2 times negative 2 first and then square the result. Remember, you got to do exponents first. Negative 2 squared is positive 4. So we end up with 2 times positive 4 minus 5. 2 times 4 is 8. You end up with 8 minus 5, or a equal to 3. To find b, you have to use the expression 3x minus 9. When x is negative 2, you get 3 times negative 2 minus 9. 3 times negative 2 is negative 6. Negative 6 minus 9 is negative 15. So now you have to add together 3 and negative 15. Not add together, excuse me, you have to subtract. You're going to take a and subtract b. Well, a is 3. You are subtracting b, which is negative 15. And remember, when you subtract a negative, it's the same as adding. 3 plus 15 is 18. The answer is D. And in number 6, which expression is equivalent to? Let's come down here and rewrite the expression. This is just a fancy way of asking you to simplify this. Get it in its most simplified form. First step is always to get rid of parentheses by distributing. You don't distribute the 2x through the parentheses, just the number directly in front of the parentheses, the negative 4, leaving you with 2x. Negative 4 times 2x is negative 8x. Negative 4 times 6 is negative 24, minus 7. Now you can combine these two like terms and these two like terms. 2x minus 8x is negative 6x, Negative 24 minus 7 is negative 31. And you see that choice C is the answer there. For number 7, it says Curtis wrote the expression 7x plus 2. Gianni wrote the expression 2 plus 7x. Curtis claims that their expressions are equivalent, which means they're the same. Which property justifies Curtis's claim? Well, we basically took the 7x and the 2 and we reversed their order around an addition sign. The commutative property is the property that deals with reversing the order around an operator. For number 8, the most common mistake with number 8 is students forgot to apply the exponent of 4 to the coefficient of 4 inside the parentheses. So remember, this is the same as 4 to the 4th power times x to the 3rd to the 4th power. 4 to the 4th power means 4 times 4 times 4 times 4. Do that on your calculator, you see it's 256. And when we have a power raised to a power, the shortcut is to multiply the powers. You end up with 256x to the 12th power. Choice D. Nine, again, you're asked to just simplify. So you're going to use whatever properties you know of to get this down to its most simplified form. Distributing here, 3x times 3x is 3x squared. 3x times negative 2 is negative 6x. Negative 4 times x is negative 4x. And be careful here, negative 4 times negative 2 is not negative 8, and negative times a negative is a positive. Negative 4 times negative 2 is positive 8. You can combine these two middle terms. You end up with 3x squared. Negative 6x minus 4x is negative 10x. And you have a plus 8 hanging off the end. The answer was choice C. Now, a lot of kids were confused about number 10. It says, at the concert, the number of people entering through gate A is 3 parentheses x plus 1. So basically, they're representing a number of people with an expression. The number of people entering through gate B is just simply 3x plus 1. Compare the number of people using gate A with the number of people using gate B. Well, when I look at the answer choices, C says the number of people entering through gate A is the same as the number of people entering through gate B. If that were true, then that would mean this expression is equivalent to this expression. Well, let's distribute and see if that's true. 3 times x is 3x. 3 times 1 is 3. As you see, these are not equivalent, so choice C cannot be the answer. Well, which one would result in more people? And remember, this one here represents gate A. This one here represents gate B. No matter what number you plug in for x, isn't this one going to yield more people because you're taking 3x and adding 3, where gate B is taking 3x and only adding 1? So comparing the two expressions, you see that more people enter through gate A than through gate B. Now in part 2, you had to simplify the expressions using the properties we've discussed in class. This first one was worth 1 point because you get your answer in just one step. You have to distribute to get rid of the parentheses. The most common mistake here is that many kids told me that 4x times 2x is 8x. Be careful, it's 4x to the first times 2x to the first. 4 times 2 is 8. X to the first times x to the first. When you add those exponents, you get x squared. 4x times negative 6 is just negative 24x. You cannot combine those because they're not like terms. An x squared cannot be combined with an x to the first. Okay, letter B, I can't tell you how many kids double distributed using multiplication. You have to be very careful. In the middle here, you see a plus sign. You're being asked to add these two binomials. And remember, when we're adding, we can just drop the parentheses and keep all the signs the same. So we have 2x minus 8, we have a positive 3x, and a negative 5. Combining your like terms, you get 2x plus 3x, which is 5x's. And you have negative 8 minus 5, which is negative 13. You're done. So a lot of you made that one a lot harder than it needed to be. You were simply just combining like terms because you were adding, not multiplying. This next one is just a bunch of terms. There's no parentheses. You're just going to add. Or, in other words, combine like terms. I shouldn't really say add because there is a minus in there. If you want, you can group your like terms. I have a 5y. I have a minus 3y. I have a negative 2x. I have another negative 2x. I have a positive 6. And I have a positive 8. Sometimes it's easier to group your like terms, so you just can work from left to right. 5y's minus 3y's is 2y's. Negative 2x minus 2x is negative 4x. And 6 plus 8 is 14. That's your answer. You can't combine anything else. You don't have any like terms. This is a plus sign here. Now D was the one where probably 2 or 3 of you got it right. I don't know if you were rushing. Since the test, we spent a whole day practicing squaring a binomial. You can't just square the x and get x squared and then square the 3 and get 9. That's incorrect. Because when you square something, you have to take that something and multiply it by itself. This is what you're really doing if you expand it out. And so you have to double distribute. X times x gives you x squared. X times 3 gives you 3x. Taking the second term through the second set of parentheses, 3 times x gives you another 3x. And 3 times 3 gives you 9. Combining your like terms, in standard form, the answer is x squared. 3x plus 3x gives you 6x plus 9. Final answer is x squared plus 6x plus 9. Very common mistake. So make sure if you see something like that, stretch it out. So once you see this, I think you'll remember you have to double distribute. Okay, and letter E, look between those parentheses. You don't see a plus or a minus, so that means you're multiplying. You're going to do x times x, which gives you x squared. You're going to do x times 5, which gives you 5x. Now you're going to distribute the 4. 4 times x gives you 4x. 4 times 5 gives you 20. A lot of you had plus 9 down here. Remember, when you're distributing, you're multiplying, not adding. Combining your like terms in standard form, you get x squared. 5x plus 4x is 9x plus 20. That's your final answer in simplified standard form. Letter F was another one that I almost did a whole class on because many people got this one wrong. This is division, which most of you recognized, and the rules for dividing are you divide the coefficients and subtract the exponents. But a lot of students didn't end up with 1, 2, 3 terms in their answer. If you're dividing 2x squared into 3 different terms, you should have 2 terms in your answer. So when you see one like this, my suggestion when we worked on dividing, let me erase that, was to write it this way. Rewrite the problem as 10x to the 8th divided by 2x squared. minus 4x to the 6th divided by 2x squared plus 2x squared divided by 2x squared. If you rewrite it, instead of having one common denominator separated into 3 fractions with a common denominator, you might recognize or realize or remember that you need 3 terms in your answer. 10 divided by 2 is 5. X to the 8th divided by x to the 2. Subtract the exponents, you get x to the 6th. Negative 4 divided by 2 is negative 2. Oh, I made a mistake here. I apologize. That should not be a 2. In the top here, actually, what we have is 4x to the 6th. That should be a 6. Sorry about that. X to the 6th divided by x squared is x to the 4th, because 6 minus 2 is 4. A lot of you left this last term off because you thought the 2x squared in the top canceled with the 2x squared in the bottom, and so that there was nothing left. Remember, that's not true. Whenever the top of a fraction is equal to the bottom of a fraction, it's no different than 5 divided by 5 or 10 divided by 10. What you get is 1. Your final answer is 5x to the 6th minus 2x to the 4th plus 1. Now letter G was tricky because you had some addition going on here and some multiplication going on in the middle. And if you remember PEMDAS, you have to take care of multiplication before you can take care of addition. So I brought this 2x down, and then I double distributed here. X times x gives me x squared. X times negative 8 gives me negative 8x. Taking the 6 through, 6 times x gives me positive 6x. 6 times negative 8 gives me negative 48. And then I have a plus 2x squared hanging off the end. Combining like terms, I have a 1x squared and a 2x squared, which leaves me with 3x squareds. I have a 2x minus an 8x. That gives me negative 6x. When I take negative 6x and I add 6x, I get 0. So these x's do cancel out. The only thing left is negative 48. My answer is 3x squared minus 48. Many kids for H put 0, again because they thought the top canceled with the bottom and there's nothing left. This problem is no different than 10 divided by 10, which is 1. Whenever the top of a fraction is being divided by that exact same thing, the answer is 1. Not 0, but 1. And if you actually use the law of exponents, you'll see that when you divide, you subtract the exponents. You end up with m to the 0, because 4 minus 4 is 0, times n to the 0. 6 minus 6 is 0. Well, we know that anything to the 0 power is equal to 1, and 1 times 1 is 1. Part 3 was short answer. Number 1, you had to evaluate this expression when x is 2 and y is 3. So on the top you get 5 times x, which is 2, squared, divided by 3 times y, which is 3, minus 4. Many people ended up with the answer of 20 because they did 5 times 2 and got 10, and then squared 10 and got 100. You have to be careful with that. PEMDAS tells you to do exponents before you multiply. So 2 squared is 4. The top becomes 5 times 4. 3 times 3 is 9, so the bottom becomes 9 minus 4. 5 times 4 in the top gives you 20. 9 minus 4 in the bottom gives you 5. And 20 divided by 5 gives you a final answer of 4. For letter B, I saw a lot of lines being drawn like this, as if you were doing some kind of distributing. Remember, distributing is only done when you're multiplying a number through a difference or a sum. This is not a difference or a sum. This is just one term multiplied by another term. So you just have to multiply the coefficients. You're going to do 6 times 2. You're going to multiply the x's, x to the 7th times x to the negative 9th. And you're going to multiply the y's, y to the 3rd times y to the 2nd. 6 times 2 gives me 12. When I multiply like bases, I add the exponents. 7 minus 9 is negative 2, so I get x to the negative 2. And y to the 3rd times y squared is y to the 5th. 3 plus 2 is 5. The directions clearly say in bold print, write your answers using only positive exponents. The 12 is to the first power. It has a positive exponent, so it gets to stay put right where it is. The y to the 5th has a positive exponent, so it could stay right where it is with the 12. However, the x to the negative 2, that's a negative exponent. To write that x to the negative 2 as x to the positive 2, you got to bring it down below. Many people forgot what perimeter meant. Perimeter of a square means you add all these sides. You add this side to this side to this side to this side. Well, the side length is being represented by 4x plus 3. So you can do 4x plus 3 plus 4x plus 3 plus 4x plus 3 plus 4x plus 3. You're adding all the sides. Many of you did this because you know in a square all sides are equal. You just did 4 times 4x plus 3. I don't care which method you used. Both is correct. Now those of you, all of these were worth 2 points. Those of you that put this or this on your answer blank got 1 out of 2. And that's because it's not in most simplest form and the directions say write your answer in simplest form. So for example, if you're using this expression here, you'd have to distribute. 4 times 4x is 16x. 4 times 3 is positive 12. So the expression that represents the perimeter is 16x plus 12. Perimeter is adding. Letter D is about area. Area is when you multiply the length times the width. In this case, the length is 2x to the 4th plus 3x. The width is 10x squared. So I'm actually going to rewrite this as the width times the length because multiplication is commutative. I'd rather have my smaller side length up front. There's my width. I'm going to multiply that by my length. Those of you that wrote that on your answer blank there got 1 out of 2 points because you're absolutely right. That is an expression to represent the area of this rectangle. However, it's not an expression in simplest standard form. To get it there, you have to actually distribute. 10x squared times 2x to the 4th gives you 10 times 2, which is 20. X squared times x to the 4th. You add the exponent, you get x to the 6th. 10x squared times 3x to the 1st. 10 times 3 gives me 30. X squared times x to the 1st gives me x to the 3rd. You cannot combine these two because they're not like terms. This has a 6 as an exponent, this has a 3. So this is the area of the rectangle in its most simplest standard form. Alright, so this page, not many people got all 6 of them correct. These are tricky. There's just a lot of room for error in problems like this. The most common mistake here is students did not apply the exponent of 3 to the coefficient of 3. So which is why I always suggest rewrite this. Applying that exponent to both pieces on the inside, you get 3 to the 3rd power times z to the negative 2 raised to the 3rd power. Well, 3 to the 3rd power is not 9. Many of you are still, when you have a number to a power, you're multiplying the number by the power. That's not what raising something to the 3rd power means. 3 to the 3rd power means do 3 times 3 times 3. 3 times 3 is 9. 9 times 3 is 27. And when you have a power to a power, you can multiply the powers. You end up with 27z to the negative 6 power, because negative 2 times 3 is negative 6. You were asked to write your answers using positive exponents only. So your final answer is 27 in the top, because 27 is raised to the first power. It's got a positive exponent, so it could stay right where it is. To make z to the negative 6 positive 6, you need to bring it down below. Z to the 6 comes down below. In number 2, you had to take care of the powers to the powers first before you can do the multiplication. 2 times 3 is 6, so this term becomes x to the 6. We're going to multiply this by this term. 3 times 4 is 12. You get x to the 12th. Now you have a simple multiplication problem. The bases stay the same. You add the exponents. There's your final answer. This one's very similar to number 1, except we have a denominator as well. So I'm going to apply that exponent of 2 to everything in the parentheses. In the top I get 2 squared times y to the 3rd squared divided by y to the negative 2 squared. 2 squared is 4. When I have a power to a power, I can multiply the powers. I end up with y to the 6 in the top. In the bottom, negative 2 times 2 is negative 4. I end up with y to the negative 4 in the bottom. So this is really 4y to the 6 divided by 1 y to the negative 4. It's a division problem. Dividing your coefficients, 4 divided by 1 is 4. When you're dividing, you subtract the exponents. Be careful, this is not 6 minus 4. You do the top minus the bottom. 6 minus negative 4 is really 6 plus 4, or y to the 10th. 4y to the 10th was the final answer there. For this one, again, we're dividing. Don't forget this x is really x to the first power. The base stays the same. Subtract the exponents. 5 minus 1 is 4. For the y's, the base stays the same. You subtract the exponents. 3 minus 7 is negative 4. But because we have to write our answer using positive exponents only, the x to the 4th has a positive exponent. It stays right where it is. The y to the negative 4th must come down below to become positive. Remember, this in number 5, 25x squared divided by x to the negative 3rd is the same as 25x squared divided by 1x to the negative 3rd. Another division problem. 25 divided by 1 is 25. The base stays the same. And you subtract the exponents. Be careful. You're not doing 2 minus 3. You're doing the top exponent minus the bottom exponent. It's really 2 minus negative 3, which becomes 2 plus 3, or 5. No negative exponents, so you're done. Now, many of you here got 1 squared as your answer, and I know exactly what you did wrong. You divided 4 by 4. Very common mistake, because we divide the coefficients like we did here. 25 divided by 1 gave us 25. However, in this problem, the 4's are not coefficients. This would be different. If it said 4x to the 8th divided by 4x to the 6th, in this case you would divide the coefficients. 4 divided by 4 is 1, and you would subtract the exponents. 8 minus 6 is 2. Different than the problem here. In this case, the 4's are not acting as coefficients, they're acting as bases. And the law of exponents for division tells us that the base stays the same and you subtract the exponents. So if you look back at the directions, it said write your answer using positive exponents only. You could stop right here. You've got an answer with a positive exponent. If you took it one step further and wrote 16 and circled it, you got the point if you had this there as well. But if you just went to your calculator and did 4 raised to the 8th power divided by 4 raised to the 6th power and wrote your answer as 16, you lost the point. because you did follow the directions, you didn't write the answer using positive exponents only. And lastly, the bonus problems. We had a multiplication one on this side and a division one on this side. We'll start with the multiplication. First thing you got to do is apply this exponent of -3 to all three pieces on the inside, giving you 6 to the -3 times x squared to the -3rd power times y to the 3rd to the -3rd power. And we're going to apply this power of -2 to all three pieces in this set of parentheses, leaving us with 4 to the -2 times x to the -2 raised to the -2 times y to the -3 raised to the -2. I really haven't done anything except remove these parentheses and apply the exponents to all the pieces inside. Now, here's a negative exponent. Remember, in a negative exponent, when you have a number raised to a negative exponent, it's the same as 1 over that number raised to the positive exponent. So 6 to the -3 becomes 1 over 6 to the 3rd. When we have a power to a power, we multiply the powers. 2 times -3 is -6. 3 times -3 is -9. 4 to the -2 is the same as 1 over 4 squared. -2 times -2 is -4. -3 times -2 is -6. Now what we've done here is we've created a multiplication problem where we will multiply the coefficients and subtract, and add the exponents, excuse me. Now 6 to the 3rd power is 6 times 6 times 6. You could have done that on your calculator. You get 1 over 16, or I'm sorry, 1 over 216. 6 times 6 times 6 is 216. And I'm going to multiply that by 1 over 4 squared, which is 1 over 16. I'm going to multiply x to the -6th times x to the -4th. I'm going to add those exponents. -6 times, or plus -4 is -10. We get x to the -10. Now the y's, y to the -9th times y to the -6. You add those exponents. You get y to the -15th. Well, the 216 is to the first power down here. The 16 is to the first power down here. So as far as the fraction goes, the 1's going to stay in the top. The 216 and the 16 can stay in the bottom, but let's multiply them at least. 216 multiplied by 16 gives me 3,456 in the bottom. This is obviously raised to a negative exponent. It must come down below to become positive. This one's also raised to a negative exponent. It must come down below to become positive. Your final answer being 1 over 3,456, x to the 10th, y to the 15th. This one's a little different. You only have parentheses on the top. So you only have to apply this power of 3 to these three pieces here. Using the power to the power rule, you can multiply the powers. -5 times 3 gives me x to the -15. -5 times 3 is -15. Y to the 6th raised to the 3rd power. Again, you can multiply 6 times 3, you get y to the 18th. Z to the -3rd raised to the 3rd power. Again, multiply those powers, you get z to the -9. -3 times 3 is -9. A little messy 9 there, let me fix that. And then not much better. In the bottom we have x to the -3rd, we have y to the 7th, and we have z to the 3rd. Now we need to divide. When we divide, we subtract the exponents. You got to be very careful with your signs. The x stays the same, but you're doing negative 15 minus negative 3, which is really the same as negative 15 plus 3, which is negative 12. The y stays the same, and you're doing 18 minus 7. 18 minus 7 is 11, so you end up with y to the positive 11. And then your z is also going to stay the same. And you're going to do negative 9 minus 3. The top is negative 9, you're subtracting the bottom, which is positive 3. Negative 9 minus 3 is negative 12. You end up with z to the negative 12. Let me just make this neater. So you'll see we have some negative exponents there. We can't have negative exponents in our answer. So we need to move some things. The y to the 11th has a positive exponent. It gets to stay put. Y to the 11th. The x to the 12th must come down below to become positive. And the same with z to the negative 12th must come down below to become positive. There's your answers. So again, if you have any further questions, if there's still any that you're not sure about, go back, rewatch my explanation, and then come see me if you still have questions.